Node.js is event-driven, designed to handle asynchronous tasks like API calls and database requests without blocking the main thread. Its single-threaded event loop makes it perfect for I/O-heavy operations. This architecture excels in backend web apps where short, non-CPU intensive tasks dominate. The key part here is the single-threadedness of the Node.js event loop. It normally handles the tasks on the main thread, which means that you are not able to leverage, in normal circumstances, multiple threads offered by your CPU. But Node.js has an ace up its sleeve, where it actually can leverage multiple threads. But more on that later. So here are a few key components of Node's architecture. The application and modules. This is where all the JavaScript code lives. Your application code, Node.js core modules, any npm installed modules, and the ones you write yourself. This is the part you'll spend most of your time working on. Node.js uses the V8 JavaScript engine to execute JavaScript code. V8 is an open source project primarily developed and maintained by contributors to Chromium, which is sponsored by Google. Written in C++, it's also used by browsers like Chrome, Brave, and Edge. Bindings are like bridges that connect your JavaScript code to the high-performance C and C++ code powering Node.js under the hood. Node uses plenty of C and C++ because it's fast and efficient, but JavaScript can't natively talk to it. Enter the bindings, which act as the translator between these languages. They allow your JavaScript to interact with core C libraries like C-Ares, zlib, and OpenSSL, among others. This approach boosts performance and promotes code reuse by leveraging existing C code instead of reinventing the wheel in JavaScript. Node uses libuv, a multi-platform library that provides asynchronous I/O and other features to Node.js, enabling it to handle multiple connections and tasks simultaneously. Libuv is of course written in C. Event loop is a part of libuv. It continuously checks the event queue for pending events. It efficiently handles callbacks, ensuring non-blocking execution. This allows Node.js to process multiple tasks concurrently without blocking the main thread. The event loop processes events in a loop, as you'd expect from the name, triggering associated callback functions and optimizing resource usage. The event queue, also part of libuv, manages and processes asynchronous events and callbacks. It ensures that asynchronous operations like I/O tasks or timer callbacks are handled in a non-blocking manner and in the order they were received. This keeps Node.js applications efficient and responsive. Finally, the thread pool, aka libuv worker threads. It handles blocking operations like file, input and output operations, DNS lookups, cryptography, and some other CPU-intensive tasks, which are offloaded to a thread pool to avoid blocking the main event loop.